Great. Thanks everyone for your time today. Uh, Looking at the results of the poll, a lot of great feedback. There's a couple items look like they got a little more, so we'll focus on those. But as I expected, every one of those topics is important. So we're going to go through everything. There is a chat feature or a question feature on the left. If you want to put questions in there, we can get to those as we go if they're topical, or we're going to hang out at the end and wrap up everything that we don't get to. So thanks for your time again, and we'll get going. So why do we need humidification? Well, we're going to get into the physics of that in a little bit, but there's really four reasons. For people and their health, probably the most important one, and the very common reason for doing it. There's also process reasons, equipment in the building that work better for different at certain humidities, whether that be medical equipment, printing presses, everything is handling the process that they're working on and needs to be in a proper humidification level. There's also preservation of anything from artwork to woodwork, carpeting even. Lots of things that as humidification levels change, that's going to age that stuff and really prematurely have failures. When we talk about humidification for people, there's a very important range we want to consider. It's been shown to keep humidification between 40 and 60% for many reasons. The transmission of viruses is top of that list, and other things include everything you see here from the very famous Sterling study back from the mid-80s. When you talk about how humidification levels in buildings change without humidity, it's really because we take cold outside air and heat it, and we're going to look at an example of that here in a little bit. But just want to keep the focus in that 40 to 60 range. Specific examples of what happens to the human body: eyes, your throat, your nose, everything that helps you breathe and take in things from the outside is affected. So we want to keep that humidity, again, 40 to 60. There have been a number of guidelines and recommendations. The most notable in ASHRAE world is the healthcare facility standard 170. And you can see that there's a lot of different humidity levels depending on the application. So keep that in mind if you're designing for healthcare facilities, that you want to make sure that we keep within these ranges. The thing to remember and is most important is that these low levels of 20 to 40% are floors and must be kept in mind. Anytime we fall below that is when we're going to get a nonconformance. So if you have a 20 or 30% minimum, I would recommend that we design at least 5% higher than that. So you want to have a 25 or 30% range in those 20 to 60 zones, and a 35 to 40 range if your floor for your humidity range is 30. But this is also just pointing out another good place to take a look and get reference material. Let's move on to the actual physics and psychrometrics of humidification. I'm sure most of you are familiar with the psychometric chart, but we're going to go through the basics of it here real quick. It is a very important tool to help show the path that air takes during its travels from the outside to where it's being supplied, breathed, used for keeping equipment in good condition. All the reasons that we have ventilation requirements and design set points in space. So there's a lot going on here. There's a lot of lines, as you can see, so it is important to make sure we're all familiar with everything. First thing we want to show is the bottom axis there is your dry bulb temperature. Dry bulb temperature is the temperature that you measure with a standard thermometer in air. It's what is reported on the news during the weather. So it is just the temperature that is in the air at that time. On the right, the y-axis is your absolute moisture level, and absolute is important because it's a variable that does not change over temperature. You can see as you move from left to right on your dry bulb temperature line, your absolute humidity is the same. So that's an important thing to keep in mind. Absolute humidity is measured in a few different things: humidity ratio, grains, dew point. These are all ways that we express absolute humidity. Relative humidity is probably what most people are a lot more familiar with. That is expressed on the Psych chart by those curved lines that kind of parallel at the far left here without any more lines above it. That is your saturation line, your 100% humidity line, etc. So if this is your 100% RH, your saturation line, as we move lower and lower on the absolute scale, you're going to be going down in relative humidity. Relative humidity tends to be what is used when communicating air conditions throughout HVAC systems. As you size humidifiers, especially, that's typically what you're going to see. The reason for that is this blue kind of zone is a typical humidification range. And again, you see this 30 to 60% straddling your 70-75 degree dry bulb situation. So as you change in temperature here, you know, your absolute humidity is staying the same, but your relative humidity is going to be moving lower as you increase your dry bulb temperature. A quick visual of this is exactly a great way to show why we need humidification especially in the winter, drier times of the year inside. You see an example of a container with 19 grains per pound of humidification. Again, that is an absolute humidification. Absolute humidity level. If you were to take that 19 grains and take the temperature of that air from 30 degrees to 70 degrees, your moisture level stays the same. So the volume of water in that air, represented by those two cylinders, is the same, but your relative humidity level moves from 80% down to 18. So this is the exact phenomenon which requires us to get humidification. We want to get that humidity level back up, typically more, again, to the 40 to 60% range. So other lines here, these green diagonal lines are what's called wet bulb. So if you were to take that thermometer measuring your dry bulb, this is a sling psychrometer. You see on the left here a typical tool to measure wet bulb. You can, it has a wick on it that you can soak in water and then spin this device, showing what the wet bulb temperature is. Wet bulb meaning where it hits the saturation line. So that's expressed by those green lines there. Enthalpy is also important, especially if we get into evaporative humidification and cooling, which is something we'll talk about real quick. But that is how the process lines move there. Want to go through the sizing of equipment here real quick. If we were to look at a typical HVAC system with return air and outside air, the most important thing to learn is that humidifier sizing is only done on the amount of outside air. Anything that's returned is going to be already at that design condition. In this example, 70 and 40. So when we talk about sizing humidifiers, there's a couple ways you can do it. If you want just a rough estimate, typical winter humidification levels are between 2 and 3 pounds per hour per 100 CFM of outside air. So in this example, if we had 1,000 CFM, it's going to be somewhere between 20 to 30 pound humidification load. If we want to look at it a little more specifically, here's your generic formula to determine humidification load. So again, your outside air in CFM is in there. You'll want to take your outside air condition on the Psych chart in grains and subtract that from your desired condition in grains. Divide that by 7,000 because there's 7,000 grains in a pound of water. That 4.5 factor on the left side of the equation there is a correction factor for minutes to hours, and then density of air. That is important at elevation, of course. This is a sea level calculation, so it's going to be completely different if you're at altitude. So keep that in mind. But again, just as a generic example, you'll see here that we are indeed in between that 20 to 30 pound range. So these are good, very quick napkin sketch type calculations. We're going to look at some of the resources you have out there for more specific conditions. So know that there's lots of resources to help do that. And here's a number of things you can keep in mind. Remember that there's really a couple conditions we want to talk about. We want to look at your winter humidification with as much outside air as you're using. And if you're using economizer, you want to also check that condition whenever you're sizing humidifiers. There's a chance that you'll be seeing some higher humidification loads, even if you're at a slightly higher absolute moisture level, because you have more outside air that may drive your humidifier requirements. So again, keep that in mind when you're looking at it, but also when you're putting it in your calculators too. So moving on to some different options of how we can humidify. We've looked at how we're going to size the requirements. Now, how does that help drive what kind of equipment we're going to choose? There's a number of different types of systems. Here are some atmospheric steam generator options, and you can see that load does drive your decision-making process significantly. If we're to specifically look deeper into these different types of equipment, this is a typical decision tree. Is boiler steam available? That's a very typical way to humidify, is to just take boiler steam and inject it into the air. Typically, you would want to use clean steam, obviously, because of the chemicals involved in boilers. So that's why we have a steam-to-steam exchanger, unfired steam generator. Some people might call these if you have a pressurized version. So one of the main benefits of using a boiler is that you can have a central system, and since it's at pressure, it can feed multiple zones of dispersion. Once you get into isothermal atmospheric systems, those are not at pressure. Think of them like a tea kettle. So we're going to need to make sure that we have one generator or multiple generators feeding a single dispersion device, because you can't have equal pressures going in different distances. So if we are not going to use boiler steam, do we have gas? That is your most energy efficient option. They have larger capacity, so you have a bigger range you can supply and satisfy, especially above 50 pounds an hour. Those are becoming much more cost effective. You can typically get away with one generator versus multiple electric ones, is why we recommend that once you get into the above 50 pounds. If you don't have gas or it's a smaller load, typically you're going to be using an electric humidifier. And there's two completely different types of electric humidifiers. We're going to get into the difference in those. But basically, yeah, with electrode humidifiers, those require water with solids dissolved in them. That is the way that they make up, or the way they boil the water, is we pass electricity through the water. I think we're actually charging the water and using the minerals in the water to heat the water and boil it. In a resistive electric humidifier, these are resistive elements. They just get hot and boil the water that way. You can use any type of water, especially clean water, to make sure you reduce maintenance. The way you maintain an electrode style humidifier is by replacing the tank when it's full. Specifically on electric generators, here's a few examples of those. Your electrode style versus your resistive electric style. When we look at electric style, you can see here an example of the resistive elements that are in there. You can have it with integral controls or have them separate. There's lots of flexibility and options. Typically, these are the smaller ones are wall mountable. You maintain these by cleaning the tank, removing the hard water scale that develops. And again, if you use treated water, or reverse osmosis or deionized water, you may never clean the tank for years and years. So these are the benefits for resistive electric units. They are also much tighter control units, and we're going to look compared to electrode units, and we're going to look at why that is here in a second. But reasons you would choose an electrode humidifier: if you do not have tight tolerance requirements, you want to have something that's easy to maintain. You can see these cylinders that contain the water and the electrodes and boil the water. Those, when they are expended, just get removed, a new one purchased and installed, and you're back and going. So your maintenance is very easy and straightforward. Looking at how these work, and this is a very important thing that we like to always express when we're showing the comparison between these two style of humidifiers. Because we require the minerals of the water, depending on what your water conductivity is, we can only fill so much on initial fill. Your water may come in and not have a lot of minerals in it. So once we fill it as high as we can, that's as much as we can boil at that time. We boil down and refill and continue that until we get to a steady state where we have enough minerals in there to boil at capacity. And you can see this may take a significant amount of time. Again, a reason we don't want to use these in high tolerance applications where we can't get up to capacity quickly. The other thing to remember, if our nominal current on this unit was 14 amps, if we keep boiling and concentrating that water, that's going to increase above that. So we need to be leery of that and drain the water. So this is the other reason why these aren't used in high tolerance applications, is because you have to drain these units. And when you're draining, you're not making steam. We talked quickly about gas humidifiers. There's a number of reasons, again, besides your energy efficiency. There's very easy to install. You've got condensing humidifier options and seal combustion. Outdoor enclosures are available as well. Typically, these are put on roofs a lot of the time for ease of installation, and a very tight tolerance system as well. But again, gas units, larger capacities, less operating cost. Here's a shot of one of those steam exchange units that we looked at before. Again, we're going to use boiler steam to create chemical-free steam to make sure we're not putting any of those boiler chemicals into the airstream. This is an example of a atmospheric pressure one. Again, one that does not put out a pressure. There are unfired steam generators as well, where they take high pressure steam and create pressurized clean steam out. We're not going to get into evaporative cooling humidifiers very much, but just want to show a lot of the options out there. These are becoming more and more popular as the ability to cool and humidify becomes important. These, again, they do the same thing as far as humidify, but because the water for absorbing that, the energy for absorbing that water is taken from the surrounding air, that is going to cool the air at the same time as it's humidifying. All the previous steam humidifiers do not change the temperature of the air very measurably. So that is important to keep in mind. So these are optimally used when you have additional heat in the space via process or the climate. Obviously, your Southwest of the United States is very common to see these just because of the climate. So keep that in mind when you're choosing systems. The other nice thing is, especially with these bigger high pressure systems, they are at pressure. So now you're talking about supplying potentially multiple zones with a single generator. So those in very large buildings, high loads, many air handlers or zones become very cost effective. Also, remember that we want to make sure that we keep water treatment systems in mind. That greatly affects maintenance. You could have anything from as simple as a softener all the way up through RO. There's potentially even DI systems available out there too, but just know that the effort put to cleaning the water and keeping it mineral free does pay dividends back on the maintenance end of it. So all these membranes and filters are a lot easier to replace than it is to descale a humidifier tank. So keep that in mind when you're selecting systems as well. So we looked at how we generate it. Let's talk about how we put it into the air real quick. And there's two ways to do that, either with tubes in the airstream, a ductor and air handler, or if you're doing it right in space, there's different ways to do that. So we want to add a blower pack and make sure that gets put into the space with a known amount of visible cloud if possible. Here's some examples of some traditional steam injection equipment that you typically see in ducts or air handlers. The theory being, again, we have a control valve modulating your steam to your dispersion tubes and humidifying that way. The benefit of these is that potentially on different systems, this condensate that's created is at pressure and can get returned. So it makes it a little easier. We also have some high efficiency, low non-wetting distance options available. These are also very high capacity systems as well. So keep that in mind. Simple to mount, whether it be in a duct or air handler. There's all kinds of important things to keep in mind when you're selecting dispersion. But again, the idea being that these tubes have multiple orifices and are sized for the application, and pepper the air spray with multiple injection points to reduce your non-wetting distance, which especially in air handler applications is quite critical to make sure that we don't have to oversize that air handler to meet your humidification requirements. And there are a lot of options here, obviously, so make sure that you keep all these in mind. And when you work with your local representative, they're very well versed in what to do for different applications. Just want to show real quick an evaporative option and how that could get installed. You see that we again use nozzles, but these are wet systems in the duct. That's the most important thing to keep in mind, whether you do it air handler or duct. These systems, you're not going to have enough distance for complete evaporation. You're going to have 50, 70, 90% of it absorbed. The rest of it's going to get caught by a mist eliminator and drained. An option for evaporative in space is to put those nozzles you saw in that air handler and put it in right in the space, whether it be just spraying naturally or with a fan assisted system. Those are two real fine options for buildings with high open ceilings and the ability to evaporate that water. When we do this, there are no losses. Everything is absorbed. Also want to point out that, we have our standard vapor logic controller for all of these systems. All your interoperability options are there. You can put it on your building network if you want to look at these systems at any terminal in your building. And there's ways to update and download historical data if you need to troubleshoot anything. So also want to talk about how these systems fit in the building and in your HVAC system. We looked at some options for space dispersion already, but more typically you're going to see this put in the ductwork or the air handler. So typically, if you've got a system in your air handler, you want to put it in the warmest section. Now, yeah, typically if you're winter humidifying, your cooling coil is not going to be operating, so it could potentially be downstream of there. But typically, if you've got space between your heating and cooling coil, that's your optimal location. This example is showing an overall concept for a building with multiple zones that may be at different levels of humidification. So you can do your base humidification in your air handler, and then put trim humidifiers in the different spaces as needed if they have higher requirements. That gives you the best overall control and variability for the different parts of the building. How we control them is important as well. The optimal way is to use a return air sensor that gets a good mix of the space, so that you can know exactly what you're at, and then the humidifier can determine what kind of output it needs to keep that set point where it needs to be. Alternatively, you can do that in the room with the room sensor, or if you're dispersing in the room, this is your option for how you're going to be sensing and communicating to the humidifier what the what the actual condition of the room is. Want to also talk about safeties. Those are very important, especially your high limit. This is to make sure that we don't over humidify, whether that be from changing air conditions from the outside. If outside air dampers are open quickly and masses of air drive up humidifier requirements, and then they close, if you can't change your humidifier level quickly, you're going to be over humidifying and wetting the ductwork, and that's definitely what we want to keep away from. So these high limits are put typically about 8 feet down from the humidifier and set to shut off the humidifier at about 90%. And there's options where you can have a modulating high limit, where you would set a lower level, say 80%, and then just between 80 and 90, throttle back your demand, but still humidify to not fully shut off if possible. Alternatively, there is the traditional on-off systems available too. And also important is an airflow proving switch. Obviously, we don't want to be humidifying if the fan's not running. So those are typically put upstream just to make sure we don't have any wetting considerations. So want to also point out a lot of resources available to you. Great information on our website. Obviously, for product literature, if you have systems or know what you want, if you need to communicate that. However, those are all on there. There's a lot of great examples of why people are doing, or what are some interesting installations that we have out there. There's also a lot of videos talking about unit operation. There's a lot of good installation videos to help people be able to put those in a correct and timely manner, and also some tech support troubleshooting videos as well that are on demand and great resources. There's also a lot of design assistance that we've got, many handbooks that we've put out over time, design guides, just making sure that the very high level tip of the iceberg stuff that we're talking about today has a lot more that's there and available, and you can really dive in and get down to the nitty gritty on there as well. Lastly, there's a number of calculators that we've got on the website. Anything from just a basic load calc, if you want to say, I need a quick number on my humidification load, like we looked at in the beginning of this prezo, all the way through a complete detailed selection, starting with an exact humidification load, moving through all your humidification equipment and designing and expressing dimensions, clearances, electrical requirements, all the details you need to make sure you're putting the right equipment into your building is available on the website too. And most importantly is just know that you've got local resources as well. We obviously our local reps are your first resource. They are your local expert and will help you down this path. If they need a little assistance, they can always come to us here at the factory as well. But I definitely recommend you work with them through dry calc is an option. You can share projects and examples, or just communicate to them directly. And that's our show for today. If there's questions, we'll take a look at this.
Dave, I see a couple questions in the chat feature.
Okay, perfect. Yeah, I just opened that. So if you've got other questions, I'll be available until we go through them all. So please throw them in there in the question section or chat section. But looking at the couple questions that are in there right now, the first one, do the gas-fired humidifier enclosures have the option of being high wind rated? So we do have outdoor enclosures, obviously, that we're talking about here. We have seismic approvals on them, and that entails a ability to bolt those enclosures to the curb that's on the building. So we technically haven't rated them for wind, but passing actual seismic shake testing, I think, would cover you in that scenario as well. You do need to make sure you specify that when you're specifying the outdoor enclosure. So please do that as well. Another question about options of generators. What are the best types of non-pressurized humidity generators for tight tolerance, specifically plus or minus 5%? So there's a there's a lot that goes into that. I mean, in a perfect world where you have a constant temperature, I mean, that's the thing that we're kind of held to, is we need to make sure we can only humidify accurately if your temperature is fairly consistent. If you take the same volume of air in typical building temperature set points and move it 1 degree, that changes the RH 2%. So you can see that if the temperature is out of control, we're not going to be able to control very well. But assuming that your temperature control is good, I think you would want to stick with your electric resistive or your gas units, just like you're asking there, Russ. It's both of those units have the ability to modulate quickly and also the ability to keep running, 24/7 and not have to shut off like an electrode style humidifier when it has to drain. So those are exactly the right way to go. So depending on your capacity required or your utilities available, that might help you make the decision between your resistive electric or your gas units. For plus or minus 5 is absolutely achievable with electric resistive units that use very clean water, RO or DI water, and use an SSR. Then you would we've seen plus or minus 1% all day very easily. So again, some of those options are standard on some products and optional on others. So make sure you work with your reps or with us to make sure we're getting the right equipment in there. A question about how reliable are humidity sensors over time? Yeah, I think you want to make sure that you are at least annually calibrating those. Obviously, the quality of the sensor may have more to do with it. They probably have recommended numbers. Typically, your more typical systems are plus or minus 2%. So definitely calibrating them at the beginning, at the install, and using an offset if needed. That's an option in our vapor logic controller. That once you qualify your sensors, you can adjust as needed. But yeah, I would say a very regular calibration is just like any measuring devices is a good idea. Also talking about RH versus dew point, if there's a difference there, my experience has been that those are still similar quality and tolerance. Haven't seen any differences personally between an RH and a dew point sensor. I mean, which one to use is going to depend a lot on your process. Very high tolerance lab applications may benefit from a dew point or an absolute humidity sensor versus a relative one. So keep that in mind too. Question here about duct sensor. Would it be a bad location to have it in the ductwork just before it enters the room? So that's a great question about where you're sensing, whether it be for a high limit or if you need to, for whatever reason, it's not common, but if you want to put a control transmitter in the supply ductwork, which can work. There's tricks and tips and things that you want to keep in mind doing that. But if you do that, it's really important to have any kind of high limits before any takeoffs, any turns, tees, turning vanes, anything. You want to make sure you have your high limit sensor well before any of that to make sure that you're turning that humidifier off before it's going to wet anything. For a control sensor, I think that putting it right at the where it's leaving is probably your best bet. That's going to give you your best value of what the room is getting. A question about where is it best to mount the control panel on the duct or on AHU? It depends, I guess, if your steam generator has a integral or remote control panel. It really should be wherever it's going to be most convenient for your end user. If they need to get to it for anything, the keypad on most of these units is removable and can be mounted somewhere else if it's more convenient. So keep that in mind. And again, if you want to hook it up to your building management system or put it on your Ethernet in your building and monitor it from any location, that's a definite excellent way to go. Another question: are there any generators that can be installed inside of a standard rooftop unit? We do that from time to time. If the vestibule or section of the rooftop unit is temperature controlled at least between 40 and 120, though that is a fine option. It potentially gives you a short distance to run to dispersion, which should be in that rooftop unit as well. So yeah, absolutely work with your air handling manufacturer to get that put in. We wouldn't put these in the actual Airstream if that's part of the question here. These units are not plenum rated, none of these generators, so we do not want to put them into the Airstream. So there's a question here about, do we have a power trap and how high is the head if we do? We do not have a power, or what I'm assuming you mean a pumping trap that takes boiler steam and helps pressurize it back to a condensate return system. We do, and it's not, I guess, the intent of this to get into specifics besides those resistive versus electrode style electric units, but we do have a specific model of our Ultrazorb line called Ultrazorb XV that has an integral heat exchanger that re-evaporates any condensate and then takes the condensate that creates and is under pressure and can be moved or lifted. So if you need positive condensate return, that's your best way of doing that is on your dispersion system, moving it with that style dispersion panel. If you're talking about any other condensate or condensate that is from a different type of dispersion, that condensate pump would probably be required. Another question here about what if we're using a Vicella humidity sensor for Ryan for the above question about how reliable over time. I'm a little familiar with Vicella. I mean, obviously they're a very high end option. I don't recall if there's exact requirements for frequency of calibration. But the manufacturers I'm sure are going to tell you what the out of the box values for tolerance are, and then recommended calibration frequencies. So definitely work with that. I mean, just like most things, you definitely get what you pay for. Another question on steam generator tolerance about how's an STS. STS, again, depending on your airstream conditions, has the ability to do plus or minus 5. I wouldn't recommend much tighter than that. The thing about an STS is you're using a steam control valve to meter the steam that goes into the heat exchanger and therefore boiling off the amount that's going into the airstream. If you've got a very high amount of outside air is where I'd be concerned, because if we're changing the air in the space regularly, I mean, mid to high single digits or greater. So 6, 8, 10 or more. I mean, there's, some clean room or vivarium applications that get into, high double, 15, 20 plus air changes per hour. Those we want to have your resistive electric or your gas unit, depending on your capacity, to make sure that we are really changing the output of the humidifier in real time. The steam valve actuators that are out there typically take 30 seconds to a minute to open and close. So you're kind of at the whim of how quickly you're controlling the system. Also, we're using a heat exchanger in that STS to boil the water, so that once you get that thing, rocket hot and going, it's going to stay hot until it expends that energy. So just be careful. If you've got a comfort application or, couple, 3, 4 air changes per hour, I think you probably have nothing to worry about. So it's it's unfortunately, there's a limit to how much the humidifier can do, but excellent questions on those. I think that's all we got now. I'll put it up again if there's anything else that's come up to people. I'll hang on for a little bit, but like Abby said, this will be distributed after we're done here. But again, work with your local reps with questions, and check out our website. Sign up for DryCalc. There's lots of great information on there. So let us know if we need anything else.
All right, thanks, Dave. I think we can end the presentation now.
Oh, wait, one last one came in. For an operating room, is filtration? Oh, great question. So this is one that we bump up a lot. Typically, those are going to be HEPA filters, and those we don't want. We want to do everything we can to have the humidifier after any kind of high efficiency filter like that. Reason being is that they do such a great job taking everything out of the air that they even take in higher supply condition applications, they actually do take out moisture out of the air, absorbed moisture. We can't really even give a 2 or 3 times non-wetting distance recommendation, because we've seen, once you get over 65-70% RH, even fully absorbed water has been potentially an issue. So if you can put the humidifier last, and if you have to, try and make sure that you're not getting into those higher supply RH zones. And a follow-up on that, do you need higher water quality to make sure you're not contaminating the operating room? So if you're using boiler steam, you absolutely want to use clean steam, meaning reverse osmosis, deionized water, no boiler chemicals or amines in that water before it boils, especially the boiler chemicals, because they're designed to travel with the steam to make sure you're not corroding your supply piping in your building. If you're using a steam generator, an atmospheric steam generator, I'm sorry, the nice thing about that is that they're designed, no matter what your makeup water, to provide only pure water vapor. There's not going to be any carryover of dissolved minerals. They all stay in the tank. And if you're using a high pressure system or an evaporative style, that's why we require RO or DI water to make sure all of that is taken out of there. So again, it's kind of a question of, are we using pressurized steam or are we generating atmospheric steam and putting that in there? If there's ever a question, the cleaner the makeup water, the better, obviously. But know that we have put standard water, potable water units supplying operating rooms, and done it perfectly. So it's definitely not a concern. But again, keep that in mind as you're designing. Okay, great. I think that ought to do it. Thanks everyone for your time, and keep checking back. I'm sure we'll be doing lots more and different topics, next level. If you've got questions, again, let us know.
All right, Dave, feel free to end the session.
Great. Take care, everyone.